Okay, so now we're going to take what we saw in the intro video, your 6 trig functions, and apply them to what we've been learning in Algebra 2. So, I see an x-axis and a y-axis. I see an angle theta. Here's the initial side. It's a positive angle going up here. And there's the terminal side. So what we're doing is we are creating a triangle out of this angle, out of the angles we've been working on. What I want to point out is, here's the terminal side of our angle. When we form the triangle, we draw a line straight down to the x-axis. So if we get to a point where we are drawing our own triangles, which I believe we will in the next video, you are not going to connect to the y-axis to make a right triangle. That would be bad. You will connect to the x-axis every single time. You just draw that line straight down, x-axis. What that does is it gives us a right angle. So we can evaluate the 6 trig functions of theta. Well, what do we know about our 3 sides? Opposite of theta is the opposite side. So that's our opposite side. We know the hypotenuse is across from our 90-degree angle, and that third side is the adjacent side. So in order for us to do SOHCAHTOA, sine, cosine, tangent, we do want to know all 3 sides of our triangle. And we only know 2 sides right now. So what are we going to do? We're going to use our handy-dandy little Pythagorean theorem. A squared plus b squared equals c squared. Just remember, c squared has to be the hypotenuse, and that's the one we don't have, so that's what we're looking for. So a and b are our 2 sides of 4, so 4 squared plus 4 squared equals c squared. 4 squared is 16 plus 16. We have 32 is equal to c squared. So how do we get c alone? We are going to go ahead and square root both sides. So c is equal to the square root of 32. But we've been dealing with radicals so long that we know we're not going to leave the square root of 32. We're going to go ahead and break that down with a 16 and a 2. So really c is equal to 4 times the square root of 2. So I'm going to go up here. I'm going to label the hypotenuse as 4 times the square root of 2. Okay, now that we know all 3 sides of our triangle, finding our 6 trig functions actually isn't that bad. What we're going to remember for sine is that opposite over hypotenuse. So the opposite side I already labeled as a 4. The hypotenuse is 4 root 2. And then we say, well, there's our answer. Sine of theta is equal to 4 over 4 root 2. However, we're not going to leave an answer that looks like this. There's 2 things we can do. First, the 4's cancel each other out. 4 divided by 4 is 1. So that leaves us with 1 over the square root of 2. And you guys know we are not going to leave the square root of 2 in the denominator. So we rationalize it, we multiply it by itself, and our final answer is square root of 2 over 2. Sine of theta is equal to square root of 2 over 2. All right, let's find cosine. Cosine of theta is ca. So SOHCAHTOA, adjacent over hypotenuse. So the adjacent side we have labeled as 4. Hypotenuse is 4 root 2. Well, now I look at this and say, well, that's exactly what we started out with sine. So it's probably going to simplify the exact same way. So I'm just going to go ahead and say I know that that equals square root of 2 over 2. So sometimes you can go back and use your old work because these problems can be similar. All right, tangent is TOA. SOHCAHTOA. So we're going to take our opposite side, which is 4, over the adjacent side, which is 4, reduce that, and we get 1. Okay, so we've done all of that before. That's geometry. So we're going to talk about the reciprocal functions, cosecant, secant, and cotangent. So what we're going to remember is that sine and cosecant are reciprocals of each other, so those go together. So what I do is I take my sine of theta and I flip it. So 4 over 4 root 2 cosecant is equal to 4 root 2 over 4. So similar to the last one, we know that those 4's are going to cancel, leaving us with square root of 2. And that's not in the denominator because it's the reciprocal of what we did up here. So that's my cosecant answer, square root of 2. That one is done. All right, secant, we're going to remember that secant and cosine go together. So I take my cosine and I'm going to flip that 4 root 2 over 4. Similar to what we just did, those 4's are going to cancel, leaving us with just the square root of 2. And last we have our cotangent. Cotangent and tangent, those go together. That's the one that makes the most sense right here. So we take our tangent answer and we flip it. We had 4 over 4. If you flip that, it's a 4 over 4, and that equals a 1. So those are your 6 trig functions of theta, and theta came from our coordinate plane over here. Remember, we connect to the x-axis, x-axis when we form that triangle, and theta is always the angle at the origin of your coordinate plane.